What's going on, guys? My name is Amos and I'm back again with another video. Welcome to part 11 of our implementation of the most awesome automata theory library, AutonLib. So in today's video, we want to look at how we can come up with a function that is going to help us simplify the process of adding an element to the set, uh, of adding a symbol to the alphabet. So we want to see how we can, because right now what we're doing is we're doing this. Okay, we are using string duplication method. We're using it like this to add an item to the alphabet. So what we want to do is we want to see how we can come up with a function that we can use, that we can call if we want to add an item to the alphabet. So the very first thing that we want to do here is to go back to our implementation of init alphabet, because um, there also we have to make a few changes. Remember, if we go back to the structure of our automaton, if you look at the way we've defined the alphabet, here we're saying that the alphabet is defined by a dynamic array of strings. Every member is a string, and so this is a dynamic array. But then here, if we go back to automaton.c, you can see that here we are limiting. Uh, uh, Here we're defining a max size for our array. All right. So what we want to do here is to get rid of this parameter, or to get rid of this argument size t num members, and we want to initialize the alphabet, the length of the alphabet, or we want to initialize num members to 0, and each time we want to insert a new symbol to the alphabet, we will increment the num members by 1, and before that we would want to call maybe realloc to reallocate the memory to store the alphabet. So that is what we want to do. So the very first thing that we're going to do in this video is to get rid of this parameter, or of this argument size t, num members here, and we want to initialize the alphabet, uh, the length of the alphabet. We want to set it to 0 the very first time we create the alphabet. And then after that, each time we want to add a symbol to the alphabet, we'll first of all maybe check if the symbol already exists in the, because we don't want to duplicate elements in our set. So if the symbol is already there, we don't have to add it again. So let's get rid of this. Let's get rid of this parameter. All right. So we want our init to be. So we'll get rid of this, and so this gives us an error because we've deleted that. So we want to say alphabet num members is going to be equal to 0, like so. So it's going to be equal to 0. And of course here, instead of saying auton calloc, we want to call auton malloc, right? We want to call auton malloc. So I'm just going to get rid of this, and I think here everything is okay. But here we have to say auton malloc instead of auton calloc, like so, and that should get rid of that error. And then we are going to return the alphabet like this. Okay, so now each time we call this init alphabet function, this is what we're going to get. We're going to get a new alphabet whose length is going to be 0, and here we're calling auton malloc to allocate memory to store to store the alphabet, right? We're allocating memory to store the alphabet. Now this looks good. Now let's look at how we can define the method to insert a symbol that is going to help us insert a symbol to our alphabet. But before we do that, let's first of all check if the symbol already let's define a function. Maybe we're going to call it isMember. That is going to tell us if a symbol already exists in the alphabet. So this is going to return a boolean, and either we include the boo, the std boo. I think let's do that to simplify things. So we're going to say include, like so, and then we're going to go std boo, like so, because our function is going to return a boolean. It's going to return either true or false. So here we're going to say bool, and then we're going to say is member. Now, do we need to expose this function? So must this be part of our interface? So we can think about that, or maybe we can like hide this method because it's going to perform like a background check for us as we as the goal is to add a symbol to the alphabet. So this like does so I think for now we're not going to expose this function. We're just going to leave it in. It's not going to be part of our interface. So we're going to say bool is member, and what we have to do here is we have to take in the alphabet and also the symbol that we want to whose existence we want to check. So let's take in the a pointer to the alphabet. So taking the pointer to the alphabet, I'm going to say alphabet like so, and then let's take in a construct symbol. This is a string. Remember that every item or every symbol is a string or is a sequence of characters. So this is how we defined our alphabet, right? So we want to return. We're going to say, okay, let's just return. So we're going to loop through the we're going to loop through the going to loop through all the symbols, you know, of our alphabet. So we're going to say for. We're going to say size ti is equal to 0. Size ti is equal to 0, and then uh, I is less than alphabet. Alphabet dot num members like so, and then I plus plus or plus plus I. So this is what we have. So we check. So if now, because we're comparing strings, we're going to use the string compare function. And this is going to accept two strings, and it returns 0 if the two strings are equal. So string compare. So we're going to compare. Well, we're going to say alphabet, and then we're going to go members, and then we'll go I like so, and we compare it with the symbol that we have. We compare it with our symbol, and then if this is equal to 0, then we want to return true. We want to return true. Otherwise, we're going to return false, right? Otherwise, we return false. For okay, we loop. If they are equal, we return true. Now, otherwise, we want to return false. Okay. So this is what we have. This is what we have. So is member. This is how we can implement, the function is member. Now that is okay. Now let's look at how we can add an element to the set. So we're going to say bool. We're going to say I'm just going to say add symbol or insert symbol. Okay, let's call it Auton insert symbol. Auton insert symbol like so, and then we'll take in the alphabet, a pointer to the alphabet. So pointer to the alphabet. So I'm going to say alphabet like so, alphabet, and then the symbol, same thing. So const char, and then we take in a symbol like so, and so this is what we have. Now the very first thing that we have to check here is, so if first of all we verify that the symbol is, we check whether the symbol is in our set. If it's in our set, we don't want to add it again, because if we add it again, we're going to duplicate. We'll have duplicates, and that might cause a few problems later on. So so we're going to say is member, not is member. If not is member, we're going to say alphabet, because is member expects a pointer to the alphabet and also the symbol. So if the symbol is not a member of the alphabet, if it's not a member of the alphabet, and before we even do anything here, I think we have to assert we have to assert not no, like so. We have to assert that the alphabet, the pointer to the alphabet is not no. We also have to assert that the symbol is not no. Okay, if these checks are good, if these checks pass, then we can continue with our, with our logic or with the next part. So again, same thing for insert. We check that the arguments are not no, because this is very important. We don't want to continue, checking, or we don't want to continue with our with our execution of the function insert symbol or is member if the arguments are no, right? So that is going to help us take care of that. So if it's not a member, if the symbol is not a member of the alphabet, well, the very first thing that we have to do here is to reallocate. We need to call realloc, because remember that the initially the number of members here is equal to 0. Initially the number of members is 0, and so we have to be able to to be able to add one more element. We have to extend, or we have to increase. We have to extend the size of our of our alphabet, right? So, and one way to do that is we're going to call the realloc function. So what I'm going to do here is we're going to say alphabet and then members, and then we're going to call auton realloc, auton realloc. I believe we have auton realloc. Now auton realloc returns a void pointer. Auton realloc returns a void pointer. So what I'm going to do is to cast that void pointer into a char star star, right? Into a char star star, because this is what we expect. Remember, if we go back to auton.h, we look at our declaration of the alphabet struct. Members is a dynamic array of strings. Okay, members is a dynamic array of strings, and so if I cast it into char star star, that is going to give us the expected result, right? So remember that for auton realloc, let's look at what do we expect here. We expect, so we'll say alphabet, I will say alphabet members, like so, and we have to say size of, right? Because we have to insert a new symbol. We have to say we expect size. Size is the first parameter, right? So we expect size as the first parameter. So we're going to say size of, like so. Okay. We have to say size of, and then every item in the members array is a string. So we're going to say size of char star, like so, and then we multiply this. We multiply this by the current set dot length. The current alphabet length. We multiply that by the current alphabet length. So we're going to say, I think it's alphabet. Okay, not this, but we multiply this by the current length of the alphabet. So we're going to say num members, and then I'm going to say +1. Okay, +1. And now we have to provide alphabet and then members, like so. This is how we defined auton realloc, right? So we cast that into a char star star, and then we set that equal to this, and yeah, this should work. So size of char star, and then multiplied by alphabet num members +1, and then we pass in the alphabet members, like so. Okay, and we don't have to perform any check on whether this allocation was correct, or this allocation was successful. We are already doing that in auton realloc, so we just have to continue and add uh, we add to our alphabet. So we're going to say alphabet, and then alphabet members, and then before we increment the size, the size variable, or the num members variable, we have to first of all add the element, add the position, alphabet num members, like so. We're going to add our symbol, and then here it's here that we're going to say string, we're going to say str duplication, like so, and then we're going to say symbol, like so. And we also have to make sure that if we do this here, when freeing the automaton, and when freeing the alphabet specifically, we have to make sure that we deallocate this memory that we are allocating here, right? Very, very important. Otherwise, we're going to have some serious memory leaks, and that is going to cause a lot of problems later on, right? So we insert that at that position, and then we increment the size. So we're going to say alphabet. We're going to say alphabet, and then we're going to say alphabet. I believe num members is going to be equal to num members is going to be equal to alphabet num members, and then we're going to add 1 to that, right? So that is how we insert. That is how we add an element to the set. And of course, later on we'll be performing operations on automata, operations like concatenation, finding the union. Notice that the size of the alphabet of the resultant automaton is going to increase. The size is going to increase because if we're concatenating two automata, then the new alphabet is going to be the union of the alphabet of the first automata and of the alphabet of the first automata and the second automaton. So we have to find a way of finding the union of the two alphabets of the first automaton and of the second automaton. So we probably have to do that now. So we're going to define a new function, and before we do that, let's first of all expose auton insert symbol. Let's expose auton insert symbol because this is part of our interface. So I'm just going to grab that. I'm going to copy this like so, and then I'm going to go to automaton.h, and doesn't matter where you put it, I'll put it here. And we probably have to update our git repository because it's been long since we updated our git repository, right? And this is like part 11, and we've added quite a number of things, and we need to update our git. And here it complains that bool is undefined. It's because we do not include the std bool here, right? But then let's go include std bool, and we probably have to get rid of the std bool in the .c file because we are already including it here, and then in the .c file we are including this header file, so it includes the std bool in the .c file. So yeah, we have to get rid of that. You see that the error disappears here. It disappears, so we can now insert a symbol into our alphabet. And before we even what do we have here? We have an error here. It's because if you look at we have to go back to auton.h, and in init alphabet we have to get rid of this parameter, right? That should get rid of that error that we see in automaton.c, right? So it gets rid of that error, and let's try to see if things are okay. Let's use this method, or let's use this auton insert symbol to try to add symbols to our alphabet. Now the very first thing that we want to do here is we have auton init automaton like so. This is going to break a lot of things. Let's go back to how we define our alphabet, and we also have to get rid of this. We also have to get rid of this. Here we are saying num symbols. Let me go back to init automaton. Init alphabet does not take in. Init alphabet shouldn't take in an alphabet size, like so. We get rid of that, and let's also get rid of the alphabet size. So we'll only accept the num states, like so. Okay, we'll only accept the num states, and this is going to complain. So I'm going to go to, my automaton.h, look at init automaton, get rid of this size, right? Get rid of this alphabet size. So we only accept num states, okay? And let's make sure that we save that. Let's make sure that we save that. Go back to main.c. Again, we should get an error. So we get rid of that. So here we say, okay, we need 4 states, which is okay. We define our 4 states here. And for the alphabet, what we're going to do is we're going to init a new alphabet. Okay. So we're going to init a new alphabet. So we're going to say alphabet, alphabet, like so, alphabet, 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 like so. All right. Alphabet, and then alphabet, and then we're going to go init, auton init alphabet, like so. And then we're going to say alphabet, alphabet insert. Again, we have to go auton insert symbol, auton insert symbol, like so. Now this expects a pointer to the alphabet, and then the symbol we want to add. So if I say A, for example, like so, and actually what we can do here is, instead of doing this, we already have so we're going to say automaton, automaton, and then we'll go alphabet, like so, because it expects a pointer to the alphabet, right? It expects a pointer to the alphabet. So we say auton alphabet, we throw in our A. Now let me just copy this and paste it a few times, maybe 3 times, like so. Let's try to add a few symbols. Let's go B, let's go C, and then let's go D, like so. So if this works, I think this is a lot easier than doing this, because they might, instead of like using string duplication, someone might use string compare, a string copy. And if we use string copy, this is not going to work. Okay, this is not going to work if we use string copy at this particular point. So if we get rid of this and do this, I think this is going to help us get rid of some of the errors that we might run into later on. It's going to help us get rid of some of the errors. So if doing something like this is much easier, and it's safer than allowing the user, or the person who's going to be using our most awesome library, to like call string duplication outside outside the maybe in the main function, wherever they're going to be using wherever they'll need to define the alphabet for a particular automaton. So this is a lot easier and a lot safer. Now let's see if this is going to work. Right, otherwise this looks okay. Okay, this looks okay. Go back to auton.c. I see no visible errors. Same thing, auton.h, no errors. And of course, our compiler is going to help us with that. So let's clear our terminal window. And we've not made any changes to the CMake list or text file. And so we don't have to regenerate the make file. So we'll just compile with the existing make file, right? So mingw32 make. This should generate an executable if everything is okay. Okay, now things might break because we've made a lot of changes. Okay, it looks like everything compiled successfully. Don't have any errors. Now, remember that we're going to, what are we generating? We're generating a JSON file. Okay, here we're generating a JSON file. And I know it's going to like override, it's going to delete everything before like creating this new file. A complex example.json is going to delete the existing JSON file and create a new one. But I'm just going to delete it manually before we run our executable. So if I run our executable, that is going to give us a complex example.json file. And let's inspect the contents of this a complex example.json. Do we have the symbols of the alphabet? Do we have the symbols of the alphabet? If we have them, then our logic is correct. Everything is cool. We can move on to something else. Great, great job. Right. So we have A, B, C, and D as, you know, the symbols of the alphabet. Now, if you don't believe me, let's go back and try to generate a dot file instead of a JSON file, just to make sure that everything is working. So just to make sure that we also don't have problems. I think it's export dot, is it export dot stream? Export dot stream is like a low level implementation of I'm just going to go generate dot file like so. Remember, in I think 2 videos ago, I think what video number 8 or video number 9, we talked about the Duo API implementation, where we implemented the the low level, where we said that it is important to have 2 implementations for for the for generating the JSON file or and generating the dot file, because some users want a little bit more control over what they are doing. They might want to open files on their own, close them on their own, and they might also want to print the information to a different stream, right? They might also want to print information to a different stream. So we're going to provide the higher level implementation and the low level implementation. Higher level implementation for those that are not worried about closing files, opening files. They just want to generate a JSON file, generate a dot file. They don't care about printing the information to a different stream or anything like that. And then we're going to also provide the low level implementation to those that want control over what they are doing. If they want to print the information to a different stream, not a file, something like that. So and remember that our higher level implementation is calling our low level implementation in its body, right? Right. So let's go example dot. I think I'm going to go example dot example dot like so. Right. So let's compile that. I mean, let's recompile the program because we've made changes to so mingw32, that compiles, and if we go autonlib, it gives us a dot, right? So we have A, B, C, and D. So everything is okay. So everything is okay. So this looks good. So to add a symbol to the alphabet, we're going to call auton insert symbol. We pass in a pointer to the alphabet, and then the symbol we want to store. Same thing. We do the same thing here, 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 and this is a lot safer, than what we previously had, And that's all for this video. And the next video we'll look at how we can compute the union of 2 alphabets, because it's going to be very important when we talk about concatenating 2 automata, because if we're concatenating 2 automata, the result of the concatenation is going to have an alphabet that is going to have symbols from the first automaton and symbols from the second automaton. So we have to find a way to find the union of the two alphabets, and that is going to be very easy to do, because we just have to loop through the symbols. We just have to loop through the alphabet of the first automaton, and we also loop through the alphabet of the second automaton. Each time we do this, these loops, we add to the new alphabet, right? Thank you guys for watching, and I'll see you in the next video.